Hi, and welcome to Allen High School's discussion of chemistry at the pre-AP or 10th grade honors chemistry level. And we're moving into a discussion of chemical and physical properties. Now, we're going to be ultimately contrasting those to physical and chemical changes. And those are very different things. So we're going to ultimately have four things we want to distinguish: chemical properties, chemical changes, physical properties, and physical changes. So what I'd like to do before we start categorizing all of these things is let's fill in a few of our blanks. A property is a characteristic that distinguishes a substance. For example, I'm very extroverted, so my excessive extroversion, my husband says that social interaction is like an extreme sport for me. So my excessive extroversion would be considered a property or a characteristic that distinguishes me from, say, somebody who's more reserved. So we have physical properties, and these are properties of the substance itself, describing the substance, things that we could observe with our senses often, not always, but often. They can be observed or measured, and this is key. They can be observed or measured without altering the chemical identity of the substance. We are not breaking bonds. We are not forming new bonds. Okay? Now, within physical properties, we have intensive and extensive. Extensive properties depend on the amount present. So they depend on the amount of matter present. These properties vary depending on how much our sample size is present. And because of that, they cannot be used to identify, right? They can be used to describe but not identify. The next are intensive physical properties. Intensive physical properties do not depend on the amount of matter present. They are the same regardless of the amount of substance present. For example, if you wanted to know or measure the density of water, and we have a full glass, and at room temperature, it's close to 1 gram per milliliter. Close, enough for us to call it that for now. Now, if I had less water, the density is still 1 gram for every 1 ml. It's been normalized to a milliliter. So it doesn't matter how much we have. It's the same amount per milliliter. So you could take a block. I wish I could draw better for y'all. Drawing was definitely not my forte. The only artistic ability I have is I'm very, very slightly musical. Okay, so if we have a block like this, and now if I cut that block into slices, I'm not changing the density of the material. The density is the same no matter the size of the sample. And therefore, we can use density to identify a substance. Okay, we're going to come back to this list, like I said. So let's go on and fill in some more blanks. Chemical properties describe an ability, a potentiality, a possibility. So it's the potential to react. It hasn't happened yet, but the potential is there. So if you're describing me or Denzel Washington, the potential is there for Denzel Washington to meet me and have a strong attraction to me and fall in love with me. And so the potential is there. So that's just a property of Denzel Washington and myself. We could be very reactive if we met. Now, it hasn't happened. It's not an actuality. So no marriage bonds have been broken or no new marriage bonds have been formed, and honestly never will. I really do love my husband. All right? So it's a possibility in the future. So what I'd like to do with this list now is let's start by listing our physical properties. So my green highlight is going to be a physical property. So we're going to use green to highlight physical properties. So amount of energy, I'm just going to skip that. I don't like that one. We could be talking about potential energy, but I really want to hold off on that conversation. So let's talk about area. We can measure the area without altering the chemical composition. Boiling point, clarity, and color. I want to distinguish between clarity and color. Clear is kind of in opposition with the word we already used is opaque. Some people like to use clear for the word that means without color, but that is not a synonym. I will ding you on labs for that. Colorless versus having some specific color. So water we would describe as clear and colorless. Okay. Ability to conduct electricity. I can conduct electricity through copper wire without changing the copper. Ability to conduct heat. Consistency, density, dissolves in water, solubility. That has a little ambiguity to it that we'll touch on more in AP chemistry. Ductile. Ability to be molded. A better way to think of ductile is the ability to be stretched into a wire or pulled into a wire. The ability to explode. Well, if you combust something, if you burn something, you're changing its chemical properties. So you're breaking bonds, forming new bonds. That's not physical. Flammability is not physical. Hardness. I can measure hardness without destroying it. Length. Luster. Malleability is similar to ductile. I can hammer metals into a sheet. I could show you a sheet of copper. So remind me in class, I'll bring out copper wire to show you ductile, and I'll bring you a sheet of copper to show you malleable. Mass, melting point, odor, ability to react, ability to react, ability to react, ability to rush, ability to tarnish, all of those are chemical. Viscosity, do you remember our honey? Viscosity is a resistance to flow. So our honey was very, very viscous, as was our glycerin, whereas the alcohol, the rubbing alcohol, flowed very freely, and volume. Okay, those are all of our physical properties. Now let's do our chemical properties. We'll do those in red highlight. So our red highlight are going to be our chemical properties. That way we just have one list to reference. Maybe it was a good thing that my sound didn't work on our other ones. So, because I just thought of doing this and I kind of like it. All right, chemical. Well, everything else, other than we're not going to talk about potential energy. And kinetic energy is about transition and change, so that doesn't apply. So all of these others are chemical. Do you notice it's an ability to? Hasn't happened yet, but has the potential under the right situation to react or to rust combined with oxygen. All right, and I'll talk about tarnishing when we get to chemical changes. Now, those were our two broad categories, chemical versus physical. Now let's hit on which ones of these physical properties. So within physical properties, we break it down, and let me use a different color than those two to clarify. We're going to break it down into intensive and extensive. Area depends on your sample size. Area is extensive. Boiling point. The boiling point of water is very close to 100 degrees, no matter how much water we have. Intensive. Clarity, in general, is going to be intensive. Although you might argue that with me, so let's have that conversation. The intensity of color is extensive, but the color itself, the fact that it is blue, is intensive. Most, you'll notice, are intensive. Density, dissolving, its ability to dissolve in water. Intensive, intensive. Length, extensive. Depends on the sample size, how long it's going to be, right? My hair length is depending on my sample size of my hair. Luster, intensive. Malleable, intensive. Mass, depends on the amount. Extensive. Melting point. Water melts at 0 degrees Celsius. It doesn't matter how much I have. It's still going to be 0 degrees Celsius. Now, the intensity of the odor might be extensive, but the odor itself is intensive. Ammonia, remind me, I'll bring out some ammonia. Ammonia's odor is very characteristic. Viscosity is intensive. Now the time that it takes to flow would be extensive. The flow rate is going to be intensive, and volume is extensive. So now hopefully you have all of those all on one chart, and we can study from that. Now, when we look at this, we're going to distinguish some properties, and I like this question, and that is a big hint on these that I really, really, really like this question. I'm going to push the length of this video just to finish this up so that we can change subjects later. We're talking about sodium metal. It's soft. Being soft is a physical property, and its softness does not depend on the amount. And so we would call its softness, the fact we can cut through it, an intensive property. It is a silvery colored metal, as are most metals, frankly. Color is do you see that number 2 by it? That's how I'm numbering that. Silvery colored metal, it's a physical property, and it happens to be an intensive physical property. Density, I can measure the density without destroying the sodium. It would still be sodium when I was done. So that is a physical property, and we already discussed that sample size and density are constant. It doesn't matter. Density is constant with sample size, is what I'm trying to say, but stuttering over my words. So it's also intensive. If we took a 2-gram sample, well, that's a physical property because I can measure the mass without destroying the sodium properties at all, but it's also extensive. It depends on the sample size, right? Because that's kind of 2 grams is the sample. Okay, I think you got it there, I hope. When ignited, it burns with a yellow flame. That's when it is ignited. We're not saying we've ignited it. We're just saying that when it ignites, it burns, it's combustible. That makes that a chemical property. It reacts vigorously with chlorine gas, which makes that a chemical property. Melting point, boiling point. We don't change the nature of sodium. So both of those are physical properties, and in fact will be the same regardless of sample size. So you need to be able to answer questions like that, and that hopefully is not so subtle of a hint. So until then, this is signing off.